All right, hello everybody. We're going to do day 2 of graphing exponential functions. So yesterday, I'm just going to scroll back to this real quick. We just talked about what exponential growth and decay looks like, did a couple basic graphs. Really when they were just in this form, y equals some base to a power. So for today, we're going to start talking about transformations. And this is stuff that you have seen before in our class, right? First semester, we did stuff with transformations. Now we're just doing it with exponential functions. So a lot of these rules are the same. So just take a second right now and jot this down just so you know like where all these letters are located. So the A, the H, the K. So typically we just have this b to the x power, right? But then there's things that happen to it. So like here's this x minus h. So anything that says x minus h is going to shift your graph right, or it could shift left, right? Anything that does anything to the x is going to go the opposite way of what you think, right? Left or right. So h means left or right because it's going with x. And then you also have the plus k. So anything on the outside of the function, that always shifts your graph up or down, right? Anything on the outside. And then we have reflections. So that has to do with that a value being positive, or not positive, sorry, being negative, right? Now it depends on where that negative value is. So we might see a couple examples of that. But if that negative sign is outside the function, then you'll have a reflection over the x-axis, right? If that negative sign is stuck right on the x, then we're going to reflect over the y-axis, okay? As far as dilations go, that's also the a value, but we're really just looking at like the absolute value of that a value, just what number it is. So that's also kind of this green color. We're really just going to be focusing on if that number is outside the function. If we're multiplying by something, that's going to tell us if it's less than 1, we have a vertical compression. And if it's bigger than 1, again, the absolute value, then we have a vertical stretch. So compression versus stretch. There are horizontal stretches and compressions. We're really not going to deal much with those, so I wouldn't worry too much about it. Okay, so first couple things we'll do here is just kind of basic, like not looking at a picture, but just what's going on. Excuse me. So first thing we want to do is identify the parent function. So I'm just going to put PF for parent function. So the parent function is always just going to be this part, this orange part right here, the b to the x. So what's the base to the x power, right? So basically we're just looking for the base. So this one, it would just be that 2 to the x. That's just your parent function. That's the basic one, 2 to the x power. And then there are two things that are happening here. Okay, there's the x plus 1 up in the exponent, and then there's the minus 3 on the outside. So those are doing two separate things. All right, so the plus 1 up in the exponent, that's with the x, right? So that would be the h value. That's always the opposite. So that's going to tell us that we're going to go left 1. And then that minus 3 is on the outside. That's where the k is. So that tells you go up or down. Just do what it says. So that's down 3. Okay, so that one's just left 1, down 3. Okay, so then something like number 2, similar idea here. So just identifying the parent function first. It's just the base to the x power, right? So the parent function would just be 1/2. You can put it in parentheses or without, it doesn't really matter. But just 1/2 to the x. And then all the transformations, we want to say what is happening. So we have this negative sign, we have an x minus 5, and then plus 1. So there should be 3 separate things happening. So that negative sign is outside the function, so that's like this first one here. So that's going to tell us that we are reflecting over the x-axis. That minus 5 up top, that's going to say right 5. And then that plus 1 on the outside is up 1. So we would take that whole graph, flip it over the x-axis, shift it right 5, up 1. All right, why don't you guys take a second, pause me, and try number 3 on your own, and then go ahead, hit play, and you can check it. All right, so a couple things going on in this one. First of all, the parent function, hopefully you said that it is just 4 to the x, right? It's just that base to the x. 3 doesn't have anything to do with the parent function. But then there's lots going on here. So the negative tells us that there is a reflection over the x-axis. Right, it's out front. Okay, we are also going right 2, down 7, but we also need to do something with this 3. And we're just looking at the absolute value of that. So since that absolute value is bigger than 1, hopefully you said that that is a vertical stretch, right? 3 is bigger than 1 of 3. So the whole graph would just get stretched by 3. Okay? You can do number 4. It's the same thing. It's just that the parent function is e to the x. But otherwise, it's all kind of the same stuff. Okay? So now let's take those and actually do it to a graph. So I'm going to go down to number 9. All right, so kind of off to the side, I think it does help if we just kind of focus on what the parent function is. So hopefully you're thinking, well, that's 3 to the x. Okay, there's a couple ways that you can go about doing this. So you could graph the parent function and then physically just like count things on your graph and shift them like up, down, left, right, whatever. Or you can make the table. I'll do the first one, just kind of doing the graph, just so we remember how to do that first of all. So this is what we did yesterday. So we said 0 and 1 for x values. If I plug in 0, 3 to the 0 power, that's 1. Plug in 1, that's 3. So this is my parent function, right? Here's my asymptote. Always at 0, going straight up, flattening at 0. Okay, that's my parent function. But I don't want that graph. I want it with these transformations. Okay, so then kind of off to the side again, let's jot down what those are. So that x minus 1, that would mean that we're shifting right 1. And then, oops, not up. Hello, down 4. So this one's pretty easy that you have your picture already. Just take those 2 points and you shift everything right 1, down 4. So right 1, down 4, right 1, down 4. Okay, now we also need to shift that asymptote. So if you think about the asymptote, it's a horizontal line. If you shift that to the right, it's still going to stay on 0. So like left or right doesn't do anything to those. But that whole asymptote will shift down 4. Okay, and then you're just shooting that straight up, and then this is now flattening out at -4. Okay, and that's your final graph. So you can totally do it that way, right? Just draw your parent function and then count the points, right? Shift it on your graph. That's one way to do it. You can also do it algebraically. So like we already had those points 0, 1, 1, 3. Just think about like right 1, that's affecting the x's, and then down 4, that's affecting the y values, right? So for new points, if we did that, that would be like adding 1 to the x's, and then down 4, subtracting 4 from the y's. And if we look at what those points end up being, 1 plus 0, that's 1. 1 plus 1 is 2. 1 minus 4, that's -3. And 3 minus 4, that's -1, right? I just did that, add 1 to the x, subtract 4 from the y. And those are the points that I ended up with, 1, -3, and 2, -1. So if you didn't want to graph the parent function, you could do it algebraically as well. Either way would work. Okay, so then just based on that final function, just filling out all this information. So domain is all real numbers. Now the range of the final, we shifted everything down 4. So now it's -4 to infinity. The y-intercept, I'm going to come back to that at the end. That's going to be a little trickier. Our asymptote, we shifted that down 4. So now that's the line y equals -4. This graph is increasing on all x values. It's never decreasing. and then we'll do end behavior. Okay, so as x is going to the right, as x is going to infinity, what are the y values doing? They're also going up, right, to infinity. But as x goes to the left, what y value are we approaching? It's -4. Okay, so that's kind of all the same stuff we did yesterday. But now looking at the y-intercept, it was easy with just our base, like 3 to x, the parent function. That y-intercept was at 1. When I have this graph, I don't exactly know like what this point is right here, my y-intercept. So we're going to have to find it algebraically. So thinking about how you find a y-intercept, really you find that the same exact way for whatever type of function you're dealing with. You always plug in 0 for x, okay? So we have y equals 3 to the 0 minus 1 minus 4. 0 minus 1 is -1. You could do this in a calculator, not too bad though. Remember your exponent rules from Algebra 2. So 3 to the -1 power, that's actually 1 over 3. And then 1/3 minus 4, I know we love fractions. That would be -3 and 2/3. Okay, you're at -4 and you're adding a third to it. So that's why that wasn't super nice to see on the graph, but that's 0 and then -3 and 2/3. And then you have all your information. Okay. All right, let's go to the next one. This will probably just be the last one that we do. Sorry. So if you want to take a moment and pause me and maybe try this one out, decide if you want to do it algebraically or on the graph. Either way is fine. And then hit play again and we'll check. All right, so we'll start with the parent function. Should just be 1/2 to the x power. Okay, so you could come up with your points. So it's 0 and 1, plug in 0, you get 1, plug in 1, you get 1/2. Okay, as far as what's happening to this one, hopefully you notice you reflect over the x-axis. So it's going to flip down. Okay, we're going to go up 2, and that's really all that's happening. Okay, so again, you could do this visually with the graph, or you could do it algebraically. Okay, if you do this algebraically, you can do it in 1 step, but it might be easier to do it in 2 steps. So I'm actually gonna kind of move this a little bit. Shift this up. Okay, so if I took these points and I do the reflection over the x-axis. Think about what that means. Like if I just have this random point right here, if I reflect it over the x-axis, it's moving down. That random point I just picked that I'm going to erase in a second is -6, 1. If I flipped it over the x-axis, it becomes -6, -1. So think about what's changing with those points. The x stays the same. You're flipping the sign of the y, right? So that's what's happening here. When you reflect over the x-axis, you change sign of y. This is if you want to do this algebraically. So this would mean that I have -1 and -1/2, right? The x value would stay the same. Okay, now if I took that same starting point, but now I have -1 and -1/2, now I'm going to move up 2. Well, that's also affecting the y's, right? Because you're moving up. That's on the y-axis. So now I would take that and I would add 2. This is too big. Oops. Oh, gosh. Okay. So then getting my final product here, I never really changed the x's, but -1 plus 2 would be 1. And then -1/2 plus 2 would just be 1/2. Okay, so if you wanted to do it algebraically, you could certainly do it that way. So that's 0, 1, and then 1, 1/2. Now you also have to think about what's happening to the asymptote. That's super important because that's going to tell you where your graph is flattening out, right? So before it would have been at 0. Now we're changing it to be, you can't really flip a horizontal line, but it is going up 2. Okay, so I know this is going to look a little weird, but it's actually flattening out up high, and then it gets really big fast. Now that big is actually like a big negative number. It's just shooting down really fast from the left. Okay, so actually it's coming up really high. Okay, so that part can be a little bit tricky. If you did it with the graph, you're just flipping points and then moving them up 2. So it's the same exact thing, but that's what your graph would look like. So the domain of this is all real numbers. Now the range on this one, it's coming from the bottom, so it's negative infinity and going up to 2, never touching 2. We do have a nice y-intercept on this one. It's just the 0.01. Asymptote is at y equals 2. Now this one is increasing, right, from left to right. I'm looking at the x values. So it is increasing on the whole length of the graph. It's never decreasing. And as far as end behavior, as x goes to the right, what's your y value doing? That's approaching a number, which would be 2. And as x goes to the left, what's your y value doing? It's going down forever. Okay? So use those transformations, up, down, left, right, stretch, compress, reflect, and you can do it algebraically or graphically. I don't care either way, whatever you like better. Okay? So there is a lesson check available for you on Schoology for day 2. Okay? Come in with questions on this stuff tomorrow, Friday. I can answer them, and then we'll move on. Okay? All right, thanks, guys. Hope you have a good day.